Hello friends, welcome to Technomerds. In this video, we are going to learn about one of the most important topic in any software development, that is architecture pattern. And for Android, the most widely used architecture pattern is MVVM, Model View Model. We all know long form of this, but beyond this long form, what the actually MVVM model stands for, how to actually implement it in the project with the help of live data, we are going to learn in this tutorial. So live data is one of the concepts that will help us to implement MVVM architecture pattern in our project. We and all will that will be going to see in this tutorial. So let's get started. So before moving directly to the project, for just few minutes, I would like to explain theoretically what is MVVM pattern and how it actually works. So basically, as you are seeing here in the diagram, there are three different layers: view, model, and view model in this architecture pattern. So view basically contains our activities or fragments and everything which handles about UI, user interface, what we actually see on the screen. That all will be handled by the view layer. Just I have written here handles everything about UI. So here is activity fragment. Another layer we will first see a model. So basically model contains the repository, their local databases or web server APIs. So everything this shell comes into a model layer. The model knows everything about the data, where the data is stored, how to get that data. That everything model has information about all of this. So whatever component whichever component requires the data, it comes to model and asks model to give data. Model goes and gives it back to the data. And the third layer is view model. So view model is basically we can assume it as a bridge between view and model. So that's why it is called view model. So basically, the view model contains a business logic, like how our application will execute according to the business logic. So that all things will be enclosed in a view model layer. So so uh, this is about each of the layer how it performs. Now let's understand how the flow works. Let's say we have here view. So for view we have one button. So on clicking on that button, it go all of our function is to call the API and get all the details. And let's say we also have a recycler view. So get the details from the API and fill all the details in the recycler view. So for this, the activity or fragment will be in a view layer. So once we press the button on the UI, then the request will go to the view model. So view model will contain all the business logic. So view model will start executing as per our command, but view model will need a data to process further. So view model will go further to the repository, which is a part of model layer. So basically view model will go to the model, ask for a data. So hey model, I want this type of data, so please provide me that. Model will say okay. Model will go fetch the data and will provide it back to the view model. So main difference in this architecture is that view model does not directly give back the data to the view layer. Actually, what it does is, here we can see that there are observables here. So live data is basically one of the component which we can observe, and the changes will take place right after we make some changes, or it will be automatically refreshed to the UI. So in this our case, the view model got the data from the model. Now the list should be displayed whatever the data we get from the model. So for refreshing that list and setting the contents, that things are we have visibility, hide or show, that things we have handled in the view layer. But the view layer is view model is not providing the data directly to the view. Instead, view model is creating one observables and view is going to observe that data. And once the view model is completed its logic, it fills up the data with the updated, like it will fill up the recycler view with the updated data. And as soon as view model updates the data will be automatically refreshed by the view layer, because view is constantly observing whatever the data that is declared inside the view. So that is how the view model internally works. So now let's go towards our practical implementation and learn this practically, how we can implement the MVVM pattern in our application. So let's first see what we are going to build. Here I am running the application which we will be building at the end of this tutorial. So this is basically a list of names, name 1, 2, 3, 4, 5, and here at the bottom I have created one edit text and here a button. So I'll enter some name here. Let's say name 6, and I'll press a button. So as soon as I press the button, the name 6 is automatically appearing here. But I am not updating the text every time I have clicked. I am not updating the text directly. Instead, I am using the MVVM pattern and I am observing the data, and the data is automatically getting refreshed with the help of LiveData. So let's see how it is happening. We close the emulator, and here I have already set up the UI. So here is the edit text. It has an ID et name. So this is the edit text. This is a button, and this is the text view. This is not a recycler view because it will consume more of a time, and this tutorial is not emphasized on recycler view. Instead, it is just to show the how the MVVM pattern works. So here is the text view which will show all of our names in this. Here is a main activity, and I am using a data binding library in this. So let me open the module app. Here I have done the data binding enabled true. So you can just do this one and data binding will be enabled. I am using the data binding directly in this project. So for the data binding, you just have to replace your set content view with this thing. This is a binding logic, data binding logic. And for the dependencies, we have added this type of dependencies. So this one is a room database. We will be going to use the room database. So there is this is related to room. These all are, and this is related to uh, life cycle, that is coroutine, that we also need while working with this scalar database, room database. So these are the dependencies. I'll paste these dependencies in our description, so you can directly get this from those. So let me close, and yes, we are okay to proceed. So here I have restarted the application in this with this updated code, and now it doesn't have any logic other than this UI. I am typing anything and clicking on the button, nothing is happening. This is a hint, text hint of the text view, this user. So what we'll be going to do, we'll be making one database named as user, and in that we'll be just adding one entry, that is username, and we'll be enlisting those usernames one by one. We'll be able to add users to the list, and that list will be displaying here. And instead of recycler view, we are just appending the list one by one. One after the another names will appear, and that will appear in this text view, this whole text view. Okay, so for that, let us create first view layer. So I am going to here package. So in the package, I am writing view. So as I already told, the activities and fragments go into the view layer. So let me drag the main activity into this, and we can just refactor. Okay, so our view layer is ready. Now let me create another model layer. Model. So in this model layer, whatever we have to do, we first have to create some data class for some entity of our database. So let's create a data class named as user. It will be a data class, and we are going to put only one value in that is name, user name. It will be of type string, and we have to annotate this with entity because we will be using the room database in that, and this will be a table. So, and we must have to declare at least one parameter as a primary key for every table. Then we are going to declare this one as a primary key. Okay, so this will be not null. So this is the primary key. Now our table is ready. We have to build an interface. So this interface will be user the. So we create an interface that is data access object tau. We have already seen this in our room tutorial. If you don't have any idea regarding the room, then I would request you to please watch the room database first. I also have a tutorial for that on the channel itself. So I have put the link in the description itself. So you can just go on that link and check. Well, so this is the interface. So I'll annotate this with DAO tau. And in this, we'll be writing the methods to do some operations in the database. So first function, as we'll be having a list of users, first operation will be obviously to get the list of users. So here will be get users, and it will return a list of user. So I'll require a query here saying select star from user, so that we'll get a list of users. And we also want to insert an entry of the user. So we will spend one insert user. So this will have a user in as a parameter, and it will not return anything. This will we can annotate with just an insert. And if the duplicate entry comes, then what we can do, primary key on conflict strategy, we can define on conflict strategy that what we can do if the primary entry comes as a duplicate. We have here four choices: ignore, replace, abort, and none. We'll just choose an ignore, so that if name is already there and another name same entry comes in, then it will be ignored, it will not be added. So that is just the meaning of this on conflict strategy. So that is about DAO, data access object. That is done. Now I'll create one more class that will also be a data class, that will be a user response. So basically this user response what we will get, and in that we will be taking a user response that will be of list of user. So we'll be using this user response instead of list of user every time. So all these things are going into model. If you are looking here, all these things are going to the model because all these are related to storage. This is done. So we next thing we have to do is build a database for this. So I'll create another class that will be user database, and it will be an abstract class. It will be an abstract class, but it will extend from room database. Now the implementation of whatever the methods we will be creating, whatever the DAO instance we will be creating, that will be provided by the room library. Here we can also define our DAO, abstract val user DAO. It is of type user DAO. So we just have to define it here, declare it here, user DAO. So and we will be here making one companion object here, because we want to make a single instance of this database. So that's why we are making some part of this as a companion object so that we can directly access it. In this, we will be making instance where val instance colon. So this will be an instance of this database class itself, user database. This will be a nullable, and we'll initialize it as a null at first. We are creating another method here, suspend fun get instance, which will return again the instance of the same database class. We'll first check If instance equals null, then we'll create an instance here, and once created, we'll return this instance. And we need to annotate this with assertion. We need to put it as an assertion, because at this point we know that the instance will be not done, because if the instance is null, we'll be creating here, and if the instance is already initialized, then we won't be doing anything. We are just returning that instance. So at any case, this won't be a null, so we are asserting this. Here I am initializing instance equal to room dot database builder. In this, it requires three things. One is a context, and second one is a class name, and third one is a name of database, whatever name we want to give. So we'll require context here. So we'll be receiving a context here in this function. We are using the same context here. Context. Another thing is database class. This is the same class here, database double colon class dot java, and third one is the name of the db. So we can give any name. Let's give user db, user dot, or user list dot db, and we can just call the build function on this one, and that's it. Our instance is ready. So I need to make it as a var in order to let it modify, and I also make it as a private. Okay, so there is no need of suspend here. Okay, now our instance is ready. Now one thing we have to do here, that is annotation. We need to let room database know that this is a database. We have already extended this from this room database, but one thing we also have to do, that is annotation. We'll annotate this with database, and this database needs to declare some parameters in this parenthesis. So here I will be first adding an entities. Entities, basically we only have one user class. Another one is a version, that is will assign at 1. So that is the Euro database. So that is also in the model layer. Now one thing we need to do additionally for this tutorial, there is actually not need in this tutorial, but in order to learn the standard practices and to learn the room MVVM pattern, we are going to make one more class, that is repository. So I am making some repository class here. This class will basically mimic the same methods whatever we have in the database for this tutorial, but repository is more than that. In this case, you will just see like these are repeated methods will be entering in this class. But when we are working on some large project, then, and let's say we have one case where we need both data, like local data as well, and the remote API data from remote APIs from also. So for this, the view model is not going to differentiate where the data we want to load from, and it won't go accordingly to the local database or to the remote database. It will just ask the repository, give me this data, and repository will then look where this data will be available, either locally or remotely. So all these tasks will be executed, and all these things the decision will be made by the repository. The repository will contain all the data. The repository will be needing a instance here of the database, user database class. For that, we'll be making one variable, user database, that is of type user database, and in the init block itself, we will be initializing this user database equal to user database dot get instance. So that's why we have declared this method as a companion in companion object, so that we'll be able to create an instance of the database. So we'll get instance. So this get instance method requires a context. So we'll also be receiving context in the repo class also, and we'll be providing this context. Okay, now we have context. Now we can easily get the data. So we'll be making the same methods. One, get user list. What name we have given here? Get users. Okay, we'll use the same name, get users, and it will provide us with a list of user. We are calling user database dot user dot get user. Now it is giving an error because this needs to be a suspend function, and making, let's check if we have made it here suspend. Yeah, we have made. This is suspend function, and it will return this. Okay, and another method we also creating the same, insert user, and no, this method will not be returning anything, and we'll be just doing user database dot user dot insert user, and we need a user here in the parameter, so we'll have a user. Okay, these two methods are here. These two methods are redundant, but when you are working on a large project, you need to do these things for the case just I have described now. So this is our repository class. Now everything is set up. We now need a view model. So we now have a here view here, here model layer, and there is also need for the view model layer. Now let's create a new package here named as view model and press enter. In the view model, we are going to create our view model. So there is a new class. So let's name it as a main view model. Press enter. So this view model will be extended by view model. Yes, we'll be executing all the business logic in this view model. So for this view model, in this we will be creating an instance of a repository, and now repository class also needs this context, and context can provide should be provided from the view model class itself. So we will also receive parameter in the view model as a context, so that we will be able to create an instance of a repository. We will be executing all the business logic in this view model. So for this view model, in this we will be creating an instance of a repository, and now repository class also needs this context, and context can provide should be provided from the view model class itself. So we will also receive parameter in the view model as a context, so that we will be able to create an instance of a repository. So let's create instance of repository, where repository colon repository. In the init block, we are going to initialize the repository equal to repository, and we will be giving it a context. So as soon as we are creating the view model instance, initializing the view model, the repository instance will be automatically created. In the view model, as we'll be executing all the business logic here, we need to user live data here. Whatever I have done till I haven't used the live data. Here we now have to deal with the live data, so that our view should be able to automatically update itself. Like in the Kotlin, there is the version mutable and immutable version of the list. So live data is also one of the component which gives two classes, mutable live data and only live data which is immutable. So here we'll make one private variable, that is user data, and this will be of type mutable live data, and it will be a user response, of type user response. So this is a okay. So this is a private variable of the mutable live data, so that we will be able to only manipulate the value inside this user data from the view model itself and not from anywhere else. So that's why it is a private, and it is a mutable. So we'll be creating another version of this live data which will be publicly available, and it will be not a mutable, it will be an immutable live data, and we are using user data. We'll use the same name, we'll just initialize it with precede it with underscore, so that we can know that this will be a mutable version. And this is a live data of the same user response, and we'll assign a getter here, getter as user data. So as soon as the user data changes, it will be automatically updated. It will automatically update the live data, non immutable version of the live data, and we will be manipulating the mutable version of live data in case of data change. So this will be automatically updated. Now let's access the methods of the repository. So here we are going to write the same function, get users, and this function will not return anything. Instead it will get the uh, data user list from the repository, and it will set in the live data. So underscore let's first do repository dot get users. So that will give us users. Here the as it is a suspend, then we have to use a coroutine here. So here we'll use a view model scope dot launch, and we'll be using IO dispatchers here, and we'll paste this method inside this coroutine scope. Okay, now whatever the result we will be getting here, we will be collecting that in separate variable result. And now this if we hover here the result, it is of type list of user, and we have a mutable live data of type user response. So we have already seen what the user response data, class contains. User response contains the list of user. It is just a one variable user response that will hold the list of users. So we'll be converting that into the user response, and we'll set that to the live data. Now go back to the new model, and let's say once we have the result from this, what we'll do, we'll use underscore user data dot post value. We get one method here in the live data, that is post value. So we can assign the value, post the value to the live data. There are two methods, get value and post value. So get value is used to get the value from the live data, and this one is post value to post the data, to post the value to the live data. So in that it is demanding user response, so we can just create a user response object here, and inside that we can initialize a result which we have received from this database call. So that is done. Once this function is called, it will call the repository, and we'll get all the result, and we'll make a user response object, and we'll set that in the user data, which is a mutable version of live data. And as soon as it gets here, it will be automatically updating this immutable version of live data. And in the view, we will be observing this immutable version of live data, so that we can only get the data, and we should not be able to modify it. So now, and also let's declare another method also, one insert user. So that the thing will also do in the view model. We'll be receiving user, here, and this will also require a view model scope dot launch dispatchers.io and repository dot insert user, and we'll pass this user. So that's it. It will enter the user, insert the user. So that is about our view model. But let's say if we had an empty uh, if you had empty parameter, if you had no parameter in the constructor of the view model, then view model knows how to create the instance of itself. But if you have at least one parameter in the view model class, then we need to tell the compiler that how to create an instance of the view model. Because if we it is not showing a compile time error, but when we will try to run, it will crash. So for that we need to provide some factory implementation of that. For that, let's create a new view model factor here. We are creating in the same view model layer. So let's name it as view model factory. So this factory implementation is pretty simple. It will inherit from view model provider dot factory, and we need to provide and we can override here one method here, create. So we just have to do one thing. We whatever the arguments we are accepting here in our view model, that arguments we also need to accept in the view model factory constructor. So we have only one parameter, that's context. So I am accepting it here and just rub it here, and we can just create an instance of our own view model. So main view model, and we can pass this context as t. This should be a generalized, so that's why it is a t, and we are typecasting it as a t. So this is just a type of boilerplate code. It will be the same every time you will create a factory. Just you need to change the number of parameters here, and change this thing. Otherwise it will work the same without any issues. So that you don't need to worry about this class. You just need to create a override one method. So this is the work for view model factory. Now our view model is ready. We will make this also private. Okay. Now let me go to the main activity. We have now ready all the three layers. Here is model, here is view, and here is view model. We have all these three layers ready. So now let's complete the flow in order to make our application work. So here we will create a view model instance. Let in it var view model colon main view model. For initializing the view model, we have one method, that is view model provider dot get dot sorry not dot, in the constructor itself. It needs a few things. If we have factory, then we need to provide the factory, otherwise only owner will be fine. So in this case, owner lifecycle on will be this, and the second parameter is a factory. So for the factory, we need to provide view model main. Okay, I think I have named as main model factory. That is fine, no issues with that. Main model factory, and we need to pass a context here. So we can pass the context as application context, and here we can just call it dot get method, and this get method will now ask for a main model view model. That is, this is a view model factory, so it will ask for a main view model class. So we have here main view model, so we can pass it here, main view model class.java. Okay. So our view model is initialized here. So as soon as view model is initialized with the help of factory, so repository instance will also be created in the view model. So after we complete this view model, we'll make some things like binding dot button. If we click on this button dot set on click listener, if you are clicking on this button, what we need to do, we need to get the value from the user, whatever user entered there, and we just need to convert that in the encapsulate that in this user object and as a name, and we need to pass that object in the insert method of the repository. So I'll directly write view model dot insert user, and I'll create a one user object here. So that user object, the user will get from the binding dot it name dot text dot toString. So that's it. We don't need to handle the coroutine also. We have already handled that in the view model, and it will basically come to here, and in the coroutine scope it will launch, it will go to the repository, and it will execute. So here once we click the button, it will take the value and go to the we one thing we can also do, binding dot it name. After we press the button, we will be clearing the field. So dot text equal to, okay, we will be setting this to the empty text. I think dot set text might work here. Okay, this works. So we'll be setting a empty. Now we need to call the get user method in order to show the users on our layout. We want to show our all of user list one by one in the text view here in our view. For that we need to get call the view model method of get users. So we'll write view model dot get user. Okay, that's it. Now here comes the interesting part of the observing. So here in the view model, main view model, this is the user data, this is the live data we will be observing. So let's take view model dot user data. We can see that it is a live data of user response, and dot we can call the observe method here. We can click on observe. It requires two things. One is the observer, one is the owner, lifecycle owner, that is this. So this activity will be a lifecycle owner, and another parameter is observer. Inside that you can see that it is giving instance variable as a it, and it is the user response. So user, because this user data it is of type live data of user response, and in the observable the live data is getting cut off, and we are getting only the user response. Now here we can implement a logic where after the data has been changed, the control will come here automatically, and whatever the UI component we want to update after the data has been changed, we can do all the UI logic here. And what we have to do, we have to update the text view. This text view we have to update his usernames, and we want to update in a specific pattern. Every time the data is changed, what we are going to do, we will be getting this data as a user response. So we'll first take this it dot it dot user response dot, this is the actually a list of users, so we can just iterate on this for each, and we can see that it is giving it as a user. So to avoid ambiguity, I'll type this explicitly user. So we are getting a user here, and we know that in the user we have a name as a string. The name we have to provide, which have to show here in the main activity. So I will create a one names list. I will create a one string builder here, and we'll be appending the name one by one after iterating on it. So this string, I have to initialize this. Okay, so whatever the names we will be getting, we will be initializing it. We will be appending it one by one. User names dot append user dot name, and we are also appending a slash n here, so that the further name will be on the next line. And after appending, we'll here in the namespace we'll have the list of all names one by one below one after another. So we will be finally setting this in the usernames text view dot text. That will be a names list. That will do the work. So every time there is a change in data, it will be reflected. But how this will be reflected, we need to do one thing for that to work in the view model. As soon as we insert the user, we need to do these two things. So we need to do these two things. After we'll insert the data, we need to do those things. So we'll again get the user, fetch the user list, and set the data, post the data to this live data. Okay, so that will do our work. Let's try running our application and see if it works. So here our application is running, and I'll put first entry as a name 1. Click on button, and the name 1 is appeared. Here we can note that uh, we are not directly changing it. So let me do another entry, name 2, and I'll click on button. The entries came here. Now let me explain how the flow is working. Once I enter something in an edit text here and click on this button, so this button, what is this button is doing? This button on click list, now on click of this will going to the view model dot insert user. In the user, in this method, it requires a user object. So it is building a user object, and it is taking binding dot text, whatever the text user has entered here, it has taken that. And here if we go to the insert user, what is doing, it is internally receiving the user in the parameter. So this user, and here we are just launching the view model scope, and in this view model scope we that is basically for routine. In this we are calling repository dot insert user. So if we control click on this one, this user is going to pass to this here in the repository. The repository is now accepting the user. Now it is calling user DAO and insert user. So basically this is the main method where we are inserting our user, and here insert user, it is accepting user colon user, and it is inserting the user in our database. So this is doing okay. This part is clear. Now how it is updating the data? Basically in the insert user itself, what we have done is val result equal to repository.get users. Whatever the task we are doing in the get users, we are repeating it here, repository.get users. So we are if we control click on this get users, so get users is a method. We are in the repository. So repository is basically also asking user DAO to provide the result of the get users. So get users is basically user DAO method, which is annotated by this query in the interface, and here it will process, the room library will process and provide back the list of users. So once it provides the list back to the repository will return it to the view model here, and here we are collecting that things as in a result variable, and in the result variable, once we get the result variable, what we are doing, this is an important, what are we doing, underscore user data. This underscore user data, what is this? It is actually a mutable version of mutable live data, and it is actually of type user response. So it needs a user response, and there is one method that is a post value for the live data. If you want to set that set some value to the live data, we will be using this post value method, and in this post value it is accepting user response. So we are just creating a instance of user response, and we will be assigning whatever the result we are getting. We are basically making this, and after this post value, this mutable live data is getting updated. Only this thing we are doing, this user data is getting updated, so the mutable live data has been changed, and as soon as this mutable version is changed, this is also defined in the getter of the immutable version of the live data. So once this is updated, this will automatically get updated. This will because the whatever the input we are getting for this immutable version of live data, that's a mutable version of live data. So this, as soon as this live data gets updated, and we are already observing this user data in our view, in our main activity, we are observing this view model dot user data dot observe. We are observing it here, and as soon as it is updated, the control will come here, and it will basically execute the block of code. Whatever we have written a logic here, it will execute. And in this logic, what we are doing, we are looping through all the values. We are here getting the user response, and we are looping over the values, and we are setting the test. So that how it is working. We are not automatic, we are not updating the this text view on the click of the insert. We are not doing that. We are just calling the we are just calling we are just calling and setting the result to the mutable version of live data, and the mutable version is updating this immutable version of live data which we are observing. And once this live data is updated, it is automatically executing this block of code because we are observing it. So that is how the process is working, the MVVM pattern is working, the live data is working. We are not explicitly updating the view, instead these observables are updating the view once there is change in data. So the normally the tutorial might end here, but I just want to give some extra thing as you are already on my channel. So there is there is one another way of doing this. In this, we don't have to do this fetching operation again. So basically we need to do some modifications. First go to here, either method which is actually a interface of the room, which is actually doing the work behind the scenes, running the firing the query and getting the data for us. Here we are returning the list of users, but in the room database we also have facility to directly give the live data as a response. So we can use that feature of the room library here. We can directly ask here room library for the live data. We can directly return the live data from here. You just have to import this, and if you are using the live data, we don't need this suspend keyword. This is one of the most important point. If we are uh, querying the live data from the room, we don't need to use the suspend keyword. It will automatically adjust itself internally. If we are using live data, we don't need a suspend function. So I have cleared the suspend function here. We have already live data from here itself. Here I'll also rub the suspend keyword, and I'll change this return type to the live data. We'll also import it here as well in the repository. And yeah, and here we'll be going to the view model. In the view model, both of the places, here basically we don't need this, we just comment these lines, and here as we will be getting the live data inside, it will show an error. So basically what we can do is, we don't need this, we need to change the contents here. So we don't need this coroutine scope, as we don't have suspend function, we no longer have the suspend function. And here we'll be not using user response, we don't need this thing as well. Okay, sorry, we need this thing and we don't need this, we don't need this result. Instead we'll directly return this, and now this method will return a live data of list of user. Yeah, this method can directly return a live data, and we can observe this method as well. It is not like that we can only observe the variable of the live data, we can observe the method which is also providing back the live data. So we are just observing. So let's go to the main activity. So main activity, here we are using the get users here, and earlier we were not observing on this. Instead now we'll be observing on this method. Instead of this view model dot user data, we'll be observing dot get users method. Here this logic will make something, because we are no longer using the user response here, it is directly a list of users here. So we can directly iterate on the it for each, and everything else remains the same. Now if you are inserting here, then we are just making a call to the insert user, we are not again fetching these details, we are directly only calling the insert user. We are here, we are inserting, the control comes in the repository is also calling the insert user and passing the user, and that's it. It is happening when we are trying to insert, that is the only thing happening. Now let's see if this thing works. Okay, we already have name 1 and name 2, let me enter name 3. If I click on button, yeah, this is also happening. Now how this is happening? Because nowhere we are setting the data. Earlier we were doing that in a view model, we were calling the insert user, and we were explicitly making the assigning the result of assigning the updated result to the live data. Now we are not doing this, we have commented these lines, then also it's working. Now how it is working, let me explain why it is working. Once we are inserting the user, we'll go here and end up going here. Here we'll insert. Now behind the scenes, room library will insert the user, but the room library is here not providing us only a list of users, it is actually providing a live data. So as soon as this live data is now attached to the actually database of database internally, so that's why when there is any change in the database, insert, update, delete, any change in the database, that will be automatically, the live data will be automatically triggered, because live data is now holding on, is now keeping a watch on the database itself. Anything happens, modification, insert, update, delete, anything happens on the database, it will be directly creating an observable instance here, and that's why it is every time we are manipulating with the data, here we are getting the getting the new updated live data without need to explicitly change it. So that's why let's say we have inserted the user, then there is a change, live data has been triggered, and live data will again fire this thing, and we are coming back here in the repository, then again coming back to the get users, coming back to the view model get users, and this method we are observing in the view, and it will ultimately come here in the observable, and it will execute this block of code. So this is how it is happening. So this is the another approach that I wanted to share with you guys with this. There are basically these two approaches we can use LiveData and we can implement this MVVM pattern. Basically, we have only seen the two approaches of the LiveData, but the MVVM pattern is actually of this type. You can use any approach which fits you. So this is about how to practically implement the MVVM architecture pattern in our Android application. I have tried to make the concept as clear and as easy as possible. I hope that is clear to you. If still not, you can ask your doubt in the comment section below and I will try my best to answer those. If you like this video, then please click on like, share this with your friends, and if you have not subscribed to this Tech2Points channel, then please do so that you will not miss on such interesting and more valuable content. We'll meet in the next tutorial with some another great concept. Till then, goodbye, happy coding.